Let's place the interest rate on a separate line so it can be easily changed. In the previous video, we learned to create simple formulas using cell addresses, also known as cell references. Cell references allow you to include values from other cells in formulas. Cell references can be relative or absolute, and while this topic may seem complicated, it is important to understand. We discovered how to use autocomplete to replicate similar formulas in a table. Basically, autocomplete allows you to copy a formula from one cell and paste it into the next cell. This process is akin to manual copying, and we can see this in action by copying cell B7. To copy, right-click on cell B7 to open the context menu. It's called a context menu because its options vary depending on the object you right-click. This means its contents are relevant to the specific situation and displaying only the tools applicable to that object. From the context menu, select the Copy option. The cell will be highlighted with a dynamic border, indicating that its content has been successfully copied. Next, let's position the table cursor in the empty cell D6 and paste the copied information. While we could use the context menu again, let's instead use the clipboard toolbar found on the Home tab by clicking the Paste button. If we examine the formula in cell D6, we'll notice it contains a reference to cell D2. Do you understand what happened? This means that the address of the cell in the formula is taken relative to the position of the cell containing the formula. Such references are known as relative references because they utilize values from cells that are a certain distance away from the cell we are working with. Many users find this concept confusing, but understanding cell referencing in Excel is essential. Let's revisit some points from previous videos and consider an analogy that is easy for everyone to understand. As a reminder, an Excel worksheet is a table where each column and row has a unique identifier. By default, columns are labeled with letters, and rows with numbers. This allows you to uniquely identify the location of any cell on the worksheet. This is like a chessboard, which also has a similar coordinate system. This structure enables us to use values from certain cells in formulas created in other cells on the sheet. For example, if I have values in cells E2 and F3, I can sum them in cell H5. As mentioned earlier, references like E2 or F3 are known as relative references. To understand why they are termed this way, let's look at the chessboard. Imagine there is a queen positioned at E5, and pawns at C6 and B7. In this scenario, the queen represents the cell with the formula, while the pawns represent the cells containing values used in that formula. Now, envision that the pawns are strictly connected to the queen. Whenever the queen moves in any direction, the pawns follow the same path. For example, if the queen moves to E6, the pawns will also shift one cell forward, landing at C7 and B8 respectively. If the queen then moves to G4, the pawns will adjust accordingly. Now, let's say the queen moves to G1. Where do you think the pawns would end up? Pause the video and think about it. Got it? That's correct. The pawns would be at E2 and D3. But how did you arrive at that conclusion? You calculated their positions relative to where the queen was. This is precisely how Excel operates. When you copy a formula from one cell to another, the references within that formula will point to cells that are the same distance away from the new location as they were from the original. Thus, copying a formula in Excel is analogous to moving a queen on the chessboard. The main reason for misunderstanding relative referencing in Excel stems from the fact that users associate references in a formula with specific values they have entered in table cells. Therefore, when they copy a formula to another cell, they expect that the references in the formula will lead to the same table values as well. However, this is not the case. The references lead to cells that are the same distance away from the cell containing the formula as they were before. The full power of Excel is manifested in the fact that it uses relative addressing by default. When we use the Autofill feature to drag the formula down, the references in each cell shift down one row. This means the formula references point to cells that are the same distance from the new cell with the formula as they were from the original cell. This is precisely what we did in the previous video when we created our table. Relative addressing allows us to apply the same calculations to entire datasets with just a couple of clicks. However, there are situations where relative addressing is not appropriate. For example, if we need to include a constant value located in a specific cell within a formula. In this case, relative addressing will result in null values being substituted in subsequent formulas. We could create an additional column of the same size containing just that one value. But this approach could be inconvenient. It's far simpler to instruct Excel not to modify the reference during autofill. To do this, replace the relative reference in the formula to an absolute one. Unlike a relative reference, an absolute reference does not change when the formula is copied, and it always points to a specific cell within the worksheet. You can make a reference absolute by placing a $sign before the column letter and row number. As a result, when copying a formula down a column, the relative references will change, while the absolute reference will remain unchanged. You can also convert a reference to absolute by using the F4 function key. To do this, select the reference in the formula and press the key. Note that pressing the key again will cycle through different options. The $sign may appear only before the column letter or the row number. These are called mixed references, and I will discuss their usage later in this video. Essentially, the $sign locks the address change in one direction. If the column letter is locked, it remains unchanged while the row number can still change. And if the row number is locked, it remains constant while the column can change. Now, let's apply what we've learned. In cell A4 input text, interest rate. And in cell B4 input the value of interest rate for the deposit. Next, let's modify the formulas. Change the percentage value in cell B7 to a reference to cell B4. Then use the F4 key to make that reference absolute. Let's do the same for cell B8. Now, using the fill handle, we will extend the formula from cell B8 to the other cells in column B. With these updates, we can now change the deposit amount and interest rate, and the other data will automatically adjust. Let's label cell A19 at the bottom of the table with text income. Then in cell B19 input a simple formula to calculate this income, the total deposit including interest, minus the initial deposit amount. From a functionality standpoint the table is ready. However, the values could be clearer. In the next video we will apply formatting to the table cells and their contents to enhance readability. Lastly, as promised, let's delve into mixed references and how they can be applied. A classic example of using mixed references is creating a multiplication table. Let's create one on a new sheet. In the first column and the first row, create the values to be multiplied. This can be done using autocomplete. Let's input the number 1. After entering the value and pressing the Enter key, the table cursor moves to the cell below. If you want to remain in the same cell, you can use the Ctrl+Enter combination. Next, we will extend the range to the desired size, and use the autofill options to choose fill series. Do the same for the values in the first row. Now, in cell B2, we will create a basic formula to multiply the corresponding values. If we drag the autofill handle down the column, we will see incorrect results because the formula uses relative references. As a result, in each subsequent cell, one of the multipliers is incorrectly taken from the adjacent upper cell. We need to lock the row number in the relative reference. We'll accomplish this using the F4 key. Now, let's extend the formula across the range again. Everything should now calculate correctly. If we try to drag the resulting range horizontally, we will again encounter incorrect results. The relative reference in each subsequent cells points to the multiplier in the nearest cell to the left. Therefore, we need to lock the column reference for this multiplier. Let's do that and then extend the formula across the whole range using autofill again. Now the results are correct, and in just a minute, we have successfully created a multiplication table. And now, let's return to our table and apply formatting.